Hello dear student, exercise 2.2, question number 1. 3 sine inverse x equal to sine inverse 3x minus 4x cube. We have to prove this value when x belongs to minus 1 by 2 to 1 by 2. So this is the question in which we are using the proper substitution. Now we know the formula of 3 sine theta minus 4 sine q theta. This is nothing but sine of 3 theta. So in the inverse trigonometric function, the basic formula of trigonometry is very, very important. Like sine 3 theta, cos 3 theta, tan 3 theta. This value you have to remember. Now, in this case, suppose in the right hand side, if we will substitute x equal to sine theta, 3 sine inverse x, sine inverse 3x minus 4x cube. Just we have to substitute this value here. Then this will convert. So x value is sine theta. Then theta is nothing but sine inverse x. So just we have to substitute in the RHS. So sine inverse 3x minus 4x cube. Sine inverse 3 sine theta minus 4 sine q theta. And this we know this is sine 3 theta. So sine 3 theta, and this theta we have to write here. Theta is sine inverse x. So this is the left hand side value. So in this way, proper substitution is required to prove this type of problem. Similarly here we have to 4x cube minus 3x. So in place of x, we have to substitute cos theta. In place of x, we have to substitute cos theta. Then RHS is nothing but cos inverse 4x cube minus 3x. So cos inverse 4 cos q theta minus 3 cos theta. So this is nothing but cos 3 theta, and this is 3 theta, and theta equal to 3 cos inverse x, and this is the LHS value. Prove that tan inverse 2 by 11 plus tan inverse 7 by 24 equal to tan inverse 1 by 2. So this is completely formula based, that is tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y, we know the formula, tan inverse x plus y by 1 minus xy. So we have to substitute the value. So always remember, before tan there is the value is unity, and tan inverse y value is unity, and we are writing this formula. So tan inverse x plus y divided by 1 minus xy. After doing all this calculation, just we have to take the LCM and did all the calculation, and we got tan inverse 125 by 250, and this is equal to the right hand side value. So this is the right hand side value. Now question number 4. So in the third and fourth question, there is a very minute difference is there. Here in the tan inverse 1 by 2, 2 is there. So first of all, we have to convert this into the tan inverse format, and after that we will apply the formula. So 2 tan inverse x, we know the formula is tan inverse 2x by 1 minus x square. This is the basic formula. So 2 tan inverse x, we can write here tan inverse 2x. X is nothing but 1 by 2, 1 minus x square plus tan inverse 1 by 7. So after doing the calculation, this is 4 by 3, and this is tan inverse 1 by 7. So after that, this is the same problem that is based on the formula tan inverse x plus tan inverse y. So from here we will apply this formula. So this is the completely came in the formula. So tan inverse x plus y by 1 minus xy. We did the calculation and we got the result tan inverse 31 by 17. This we have to prove in the RHS. Now write the function in simplest form, and from the question 5th onwards, it is very, very important. Try to understand this type of same question they will ask in the differentiation also. You have to differentiate. So inverse trigonometric function and differentiation of inverse trigonometric function. If you know how to simplify this, then easily you can solve the problem of differentiation. So this is the proper substitution is required to solve this type of problem. Now Here we have to substitute the value x equal to tan theta. So theta become tan inverse x. So tan inverse 1 plus x square minus 1 by x. Tan inverse 1 plus tan square theta minus 1 by tan theta. And 1 plus tan square theta is nothing but sec theta minus 1 divided by tan theta. And this we will convert 1 by cos theta minus 1 divided by sin theta by cos theta. And this, after converting this, 1 minus cos theta by sin theta. Now 1 minus cos theta formula is 2 sin square theta by 2, and sin theta is 2 sin theta by 2 cos theta by 2. Here 2 will cut, sin will cut. So this is the remaining value, tan inverse tan theta by 2. This is theta by 2, and in place of theta we substitute tan inverse x. So this is the way, just by proper substitution we solve. Write the function in the simplest form. Tan inverse 1 by root under x square minus 1. Now x square minus 1, so we know the identity in the trigonometry, that is cosec square theta minus cot square theta equal to 1. So in place of x we will substitute cosec theta, so theta will become cosec inverse x. So after substituting the value tan inverse 1 by root under cosec square theta minus 1, this is cot theta, and cot theta 1 by cot theta we can write tan theta, and this is nothing but theta, that is cosec inverse x, that we can write pi by 2 minus sec inverse x, because cosec inverse x plus sec inverse x is pi by 2. So cosec inverse x we can write pi by 2 minus sec inverse x. So in this way we can write the function in the simplest form, tan inverse root under 1 minus cos x by 1 plus cos x. So here also we will apply the formula first. 1 minus cos x is nothing but 2 sin square x by 2, 1 plus cos x, 2 cos square x by 2. After doing the simplification, we can write tan inverse sin x by 2 cos x by 2, that is tan x by 2, and this is x by 2. This is the simplest form. All are very, very important for the same question is there in the differentiation. So just command on this type of problem. Write the function in the simplest form. Tan inverse cos x minus sin x, cos x plus sin x. So in this type of question, first of all, we have to divide by cos x in the numerator and denominator. So this become 1 minus tan theta, 1 minus tan x by 1 plus tan x. Now, this is the very, very important conversion is here. Whenever tan inverse 1 minus tan x by 1 plus tan x, so this value, if you will see here, 1 is nothing but, now, this is the very, very important. Tan inverse x minus 1 by 1 minus xy. This is the formula of tan inverse x minus tan inverse y. So we have to convert this in this particular format. So for that, we can write here tan inverse 1 minus tan inverse tan x. So we can write tan inverse 1 is nothing but the pi by 4 tan inverse tan x equal to x, and this is the value. Write the function in the simplest form. Tan inverse x by a square minus x square. So here the constant term is a square. So when we will substitute the value x equal to, then we will write a sin theta. Once we'll write a sin theta, then the x by a equal to sin theta, theta equal to sin inverse x by a. So tan inverse x by root under a square minus x square, just by substituting the value here, x equal to a sin theta, a square minus x square, a square sin square theta. So a sin theta, this a is common, 1 minus sin square theta, a will cut, tan inverse tan theta, theta equal to sin inverse x by a. So this is the simplest form. Write the function in the simplest form. A 3a square x minus x cube by, here also the proper substitution. Wherever the constant is there, we have to do the proper substitution. So x equal to a tan theta we will substitute. So x by a equal to tan theta and theta equal to this value. Now tan inverse 3a square x minus x cube. This is the value. Now in place of x we will substitute the value a tan theta. So 3a square minus a tan theta minus a q tan q theta by this. Now 3aq tan theta minus this is the value. Now this we can write here AQ is common in the numerator and denominator. So this AQ will cut in the numerator and denominator by taking the common. So 3 tan theta minus 10 q theta by 1 minus 3 tan square theta. This is nothing but tan inverse tan 3 theta. So this is 3 theta 3 tan inverse x by a. So this is the simplest form. Find the value of tan inverse 2 cos 2 sin inverse 1 by 2. So in this type of question where the multiple trigonometric value are in the series format, first tan inverse came, after that cos came, after that sin inverse. So we have to proceed from the left hand side, from the right hand side we have to proceed, that is from the end we have to proceed. So sin inverse 1 by 2, this we have to assume this is x. So sin x is nothing but 1 by 2, and this value is, this is nothing but sin 30 degree, and sin inverse 1 by 2 is equal to, this we can write here, sin inverse 1 by 2 is equal to pi by 6. So sin inverse 1 by 2 we have to convert into the radian format, and this we can write 2 sin inverse 1 by 2 is pi by 6. So after doing the calculation, 2 cos, after doing the calculation of this, that is nothing but 2 cos, this will cut, and cos pi by 3. Cos pi by 3 is 1 by 2, and this will cut tan inverse 1 equal to pi by 4.